Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how's life? Let me introduce myself. My name is Icha Septiana. I would like to present to you about my final project. The title of my final project is Tracking the Position of Moving Object System indoor using Signal Received Detection. Background. The number of problems regarding to the law system of surveillance of moving object in everyday life. For example, in the company, an employee comes to the office but does not do the things that should be done. So this make a detrimental to the company. Therefore, intensive monitoring is needed to all employees so that the stability of the company is maintained. So that this final project will be made an effective system to facilitate employee supervision by using the SIT UWB PK1000 development kit tool for employee monitoring. And then research purpose. To track the position of moving object in indoor field using anchor on the SIT UWB PK1000 around it by using the Wi-Fi communication module. And then problem formulation. 1. How to get ID from SIT UWB PK1000. 2. How to communicate from anchor to PK tag. 3. How to tracking position in the indoor. 4. How can server receive information from PK tag and anchor? Next, problem limitation. 1. Indoor field of observation. 2. Using the anchor as a detector of object movement amounting 4. 3. Using the tag as a signal receiver from the anchor amounting to 1. 4. PK1000 tag sends data object location information to the server. 5. The distance between the anchor and the tag using the unit centimeter. And the last, for monitor using FlyMCU server. Methodology. Literature study. Make a tracking system design for moving object in indoor with SIT UWB PK1000. Next, make a server-side program with Python programming. And then setting hardware. Next, parsing data from hardware. Next, integrate the hardware with the programming that was created. And then testing. So obtain coordinate of the X and Y position of moving object in indoor and displayed on the server. And the last, analysis and conclusion. System design. Setting the hardware, then integrating the server and hardware programs. Then put 4 anchor in different places as a detector. And 1 tag that will receive a signal from the anchor node. The content is the anchor ID. The server is connected by Wi-Fi, corresponds to the port number on the hardware. Signal strength that comes from a number of stationary anchors node is received by a mobile device node and then sent to the server in form a strong signal. On the server side, the signal strength of each anchor with a certain identity as well as the identity of the moving node will be calculated position it using the trilateration method. Data will be processed and displayed on the server. By using FlyMCU software, the coordinate of the tag are in the form of hex data which are then converted to decimal centimeter units to determine the distance between the tag and the anchor that was installed earlier. The following is an X and Y coordinate display of an anchor. And then system implementation. At the state of implementation of the system in the application of the system design that has been made before. Implementation of this system is carried in software and hardware. The software used is FlyMCU and program using the Python programming language to create program on the server so that they can receive strong signal from moving nodes and calculate position using the trilateration method. As for the hardware, it uses SIT UWB PK1000 by setting ID and installing tool. Testing system. In this test, there are 2 stages to do the testing. Testing the integration between software and hardware. The 2 stages are testing the time required to get the distance from the anchor to the tag and the comparison of the distance obtained from the data with the actual distance. Testing time to get distance data from anchor to tag serve to obtain the estimate time used to obtain distance between anchor and tag location. Then, make a comparison of the distance from the data obtained with the actual distance. The comparison serves to find out the error of the tool used. Next, is to compare the estimate position of the tag with the actual position to find out how much accuracy the UWB PK1000 tool is. Conclusion 1. Integration of hardware position and coordinate position setting in the software must be appropriate. If there is a difference in terms of setting, the position data received cannot be accurate, so that it has a large error value. 2. The system of the seat UWB PK1000 is very efficient when used in indoor locations. And the last, from the research that will be carried on in this final project, we will get the performance of the system and device implemented to obtain the best position accuracy. Okay guys, thank you for watching this video. Wassalamualaikum warahmatullahi wabarakatuh.